All right. Well, good morning, good afternoon, and good evening to everybody out there in television land. And we are in middle of day 3 of the J Champions Conference. So I'm happy to be moderating Frank Delport's talk called Looking at Music, an Experiment with Kotlin, JavaFX, MIDI, and Virtual Threads. And I had to look up MIDI again because I know that's been around a while, but it's the musical instrument digital interface. So I haven't seen
Correct.
that term in a long time, so I had to go look it up. So without further ado, Frank and Vic, please take it away.
Okay, thank you. Good evening from Belgium, and indeed welcome in this talk about music and MIDI and a lot of other stuff. So let us show you something. Hit it. So what you're looking at is a Java application, a JavaFX application, a project by two people who are here in the room, who are here presenting this thing to you. One is called Vic, he's behind me at the piano, and I'm Frank Delporte. So let us present. We will talk about melodymatrix.rocks. It's both a website and an application. We will dive into how it's created, of course. Vic is the creative person here in the room. He is a full stack musician. He plays piano, drum and guitar. He's 14 and I only have a few ChatGPT generated images, and you can immediately see why, because 14 you write it with a 1 and a 5 according to ChatGPT. He is an ethical hacker, or he wants to become an ethical hacker. He actually wants to be a hacker, and I try to convince him to be an ethical hacker. And he wants to become extremely rich, and maybe we will succeed in doing so with an application. And I'm Frank Delporte. I am 51 years old. I am a Java developer. According to ChatGPT, I should have a beard and look like this. I speak and talk a lot about Java, write a lot about Java. I am a technical writer at Azul. I have a very big interest in JavaFX, the library to create graphical user interfaces. And you can find my tutorials and experiments on webtechie.be and fujay.io, two websites where I publish my content. Now, Java for desktop. Why would you do Java for desktop? I guess most of the people looking at this talk are doing Java development, or doing Java development for backends, for Spring applications. So stuff you don't see, which is running on a server, handling traffic, doing a lot of stuff. But actually Java has this really great way of creating user interfaces with JavaFX. And we should be proud of JavaFX because it's there for a long time. You can do amazing stuff with it, and it's very stable. And it has one advantage. It's built for graphical user interfaces. It's not some kind of web technology like JavaScript that turned into a tool that everyone uses, not really for the thing that it was developed for. And then you end up with Electron applications which are way too heavy. Yeah, indeed, a bit sad, way too heavy, and do things with your computer that you don't want it to do, and use a lot of memory. And we can do better with Java and JavaFX. JavaFX is a full child of the OpenJDK project, so you can find the sources on GitHub. You can find everything there, how it's created, which are the bugs. You can file bugs, you can see how it works, and you can contribute yourself, of course, because it's an open source project. Me as a Belgian Java lover, I have to also say that JavaFX has a big Belgian site, Gluon, which is one of the main maintainers of the JavaFX library. It's a Belgian-based company, and you can find all the latest releases and early access versions of JavaFX on their websites, of course, also on the Maven repository. Another great resource, if you're interested in JavaFX, is jfxcentral.com. It's a website created by Dirk Lemmerman and his team about everything related to JavaFX, who are the people involved, tutorials, links of the week, libraries, a lot of knowledge there. And of course, it's a website created with JavaFX because JavaFX, yes, can also run on the web. So you can have a fully functional website like this, and from the same sources, a desktop application is also available, and an iOS version, and I think also soon an Android version, all from the same JavaFX sources, because yes, Java runs everywhere. So on that website, you can also find a lot of video interviews I've done with other people using JavaFX inside companies to create tools, open source development, so you can find a lot of info there. Now, how did Melody Matrix start? Vic, as I said, wants to become rich, so from time to time he has a new ID, and one of these IDs was for drums. So it's a website created to collect drum videos, and you can find a lot of them. So we use YouTube, of course, as we don't want to host all these, and he has this idea of building a community, which is pretty difficult. So we came up with a new ID based on the things he's doing on YouTube. So he has this YouTube channel, Pianoli Official, and as you can see, he creates all these amazing videos with CMusic, which is a program to convert MIDI files, or actually how you play on a piano, into very nice animations. And this is one that he just uploaded yesterday. And he creates all these, and that's the power of what these young kids can do with these amazing tools. They can create a very nice content and publish this on YouTube. And I have to say that his music channel on YouTube beats my Java channel. So music is more popular than Java. We are a bit competing for viewers and subscribers. So if you want to join us on YouTube, these are the two channels that you can join. Now, as you heard in the intro, what is MIDI? It's the musical instrument digital interface. It's a very old standard, so you can also find it as part of Java. So in Java, in OpenJDK, there is a MIDI implementation available. So how you communicate with other instruments, how you get what Vic is playing through this one USB cable to my PC, is also implemented in Java. And as you can see from the timestamp, some of this code is 7, 6, 4 years old. It's an old standard, so that means that it's stable. It's in a lot of instruments. Very old pianos already have this MIDI standard, so you can connect them to other instruments, to other devices, and to computers. As I said, it's old, so there are also some old issues there. This is one from 2015 that we are struggling a bit, is on Mac in our application. If you connect the piano, you have to restart the application. If someone can solve this old OpenJDK issue, you're more than welcome to help us. As I write a lot about Java, I also create a podcast, and as I create this podcast myself, I can select the topics. So when I started working on Melody Matrix together with Vic, I wanted to learn more about MIDI, and we have actually a Java champion who is now a Belgian guy who is now living in the US, here Vaadin. He is the creator also of Rive and Build. He is a music specialist because he works for Moog, who makes synthesizers. So he is one of the people also involved in the MIDI standard. So he's really someone who knows in depth how this works. So if you want to know more about MIDI, how it's used in Java, the history in Java and the history of MIDI, you can listen to this podcast. And also a guest in this podcast was Aisho. And he's a Japanese guy who developed a Kotlin library on top of this MIDI implementation. and that's also something we use KT-MIDI. So Atsushi Eno is his name, and he created this Kotlin library, which is compatible with Java, so it is in Melody Matrix. Now, how does it work if you touch something on that piano? How does that data get into the computer? And that's a very simple format. It's only 3 bytes. It's only 3 bytes per event of something which happens on the instrument. The first one is a status and channel. So in this 1 byte, you know if it's a note on or a note off or something else happens, like pressing the pedal of the piano. And the channel, because you can have 15 instruments in a chain. And then you have a data byte, which is dependent on what type of status is being sent. So if it's a status note on, then in the data byte will tell you which note was being pressed, and data 2 will tell you how hard it was pressed. And the same goes for other events which can happen. There are more than just note on and off. You can find a full list in this article, but of course, if you look up for MIDI, a lot of explanation is available. Now, let's look what we can do with that data in Melody Matrix. So let me close a few of these windows. So we are already connected to the piano. So we have this MIDI input here. So we get from the digital piano all the events. By the way, we also have an output, but we'll come back to that later. So we receive everything that the piano is sending as MIDI data. So if I open a table view, which is a very basic component in JavaFX, and we have one note being hit, okay, then we see, for instance, this was the C4, this is the value 60, and it was pressed with the value 103. So if he releases the note, yeah, then you see the same note with the velocity of 0. And if you press which is soft, okay, then we see 25 is the velocity. And if he presses the pedal, you will see that we have something else. We have a controller data. So this can be any kind of thing. The same MIDI data can be received from electronic drums and from other electronic instruments. So it's very easy to see what kind of data is flowing in. So let's give the floor to Vic and see what happens. So you see all these events bubbling. And actually we are just looking at data, and isn't this something a lot of us do at work? We are sending events, we are sending, make me an invoice, ship this order, this has happened in your system, this is a log message. So the way we look now at this MIDI data is exactly the same way we look at a lot of data at our job. So visualizing that data can be done in a lot of different ways, and this is only one of them. Now, because I already have this data flowing in this application through the MIDI standard, creating this view only took me 30-45 minutes. I know it's very basic, I know it deserves some love to make it more beautiful, but I just wanted to have a way to see what kind of MIDI data is flowing in, and that's what I can do now with this view. I can let him play for the rest of the hour if you want. Okay, next. Now, Melody Matrix is a pet project for both of us, so it's something we do next to our job, next to school, next to all other activities. So I wanted to focus on a few things I already knew. So for the app user interface, I'm using JavaFX. I already know that, I love it, I know what I can build with it. For MIDI, I'm using the KT-MIDI library because it does some things more than just the basic Java code which is available there. For the app code, I actually use Kotlin, and I have to tell you more about that. And for the website, I again use a few things that I already know, Spring Boot and Vaadin. I really love Vaadin. It's almost as good as JavaFX for the web browser, so you can very easily create a website and still stay purely in Java and fully create your views in Java. And that's what I've done with Vaadin. And then automated the boring stuff, deploying, building, let it handle by some automations. In this case, it's GitHub Actions and JDeploy. JDeploy packages the application for all different platforms and also make sure that it's updated. It's a pet project. That means that I made it way too complicated, of course. That's what we developers do. So it's actually 4 GitHub repositories. The first one is the distributions, so what JDeploy creates, the installers. Then I have the Melody Matrix app, which is a private repository. We want to be, Vic wants to become rich, so we have to isolate a bit of the functionality in something which is hidden that we can sell. And then the views, like the piano view that you've already seen and the table with the MIDI events, that's in a public repository. I will come back to that later. It's a demo of what can be done with JavaFX. And then the website is again a private project with Java, Vaadin and Spring Boot, and GitHub Action builds it and then SCPs it to a web hosting. Yes, the website goes offline for a very short time if we create a new version, but we don't have that critical of a thing to run. Now there are 2 things here I want to highlight. The first one is a merchant of record. If you try to sell something, if you create a digital product, being an application, a tutorial, an ebook, selling your time, please don't drive your accountant crazy. I have done that with my ebook, which is here in the paper version. Every sale becomes an invoice. Every invoice is to someone around the world, meaning that you need to take different tax systems into account. So that becomes very difficult. If someone wants a refunding, if they're not happy with what you've sold, then you have to refund them and then have to find how they paid. Please let that handled by someone else. In my case, I'm using Polar SH. So they take a little bit of your profit, but they take away all the hassle. So that's one important message of this presentation. If you want to sell a digital good, please take a merchant of record. Lemon Squeezy is another one, and there are definitely more. And then for the hosting, I'm using uberspace.de, which is a German web hoster, and they have this very nice system where you can buy a VPS and you only pay €5 per month or more if you can, but that's the minimum price they have. And I have such a server running. It has a PostgreSQL database, it runs Java, so it's very affordable. Okay, little break. Now, as I said, I'm using Kotlin. Why Kotlin? I have to admit, I was this kind of Java developer. I knew that Kotlin exists. I didn't use it yet. I was thinking, yeah, why should I use it? And then I tried it. I tried it for Melody Matrix because I also use this Kotlin MIDI library. And I found out that it's quite powerful and fun to work with Kotlin. Of course, it runs on the JVM, so we can take all the benefits of the Java virtual machine. Both JVM and Java are stable, so we're also taking benefits of those. And you can mix Java and Kotlin. I will give you an example of that. And it allows you to produce cleaner code. I have a bit of a cold, so sorry for that. I have been sick last week, so. Okay. And another thing is, if you have a pet project and you want to learn something during that pet project, you should focus on one thing. And in this project, it's Kotlin for me. So in previous projects, I was doing electronics, so that was the electronics part. But in this project, I really wanted to focus on Kotlin and how I could learn from this project. Now, let's dive in. It runs on the JVM. That means that we can take advantage of everything which happens in Java in the JVM. So we have all these evolutions. Every 6 months, we have this new version, new features, better performance, less memory use. So using Java in the JVM, make sure that every 6 months we have something which is more stable, has more features, and makes developers' life easier. And that's really what I love about Java. Like, we're using virtual threads in Melody Matrix, and we show you why we're doing that. But like switch expressions, which make code more readable, pattern matching for switch, again, same thing. Text blocks, making better readable, again, string definitions. So there's so much things changing within the JVM. And on top of that, things you don't see, like memory and speed improvements. Only when you go into your stats of your services, you will see these. But every new release brings a lot of these. Again, referring to the Fuji podcast, every 6 months we have this new version, and I talk with a few of the specialists about all the new features which are coming to Java. So please check out fuji.io. But on top of that, JVM and Java are evolving every 6 months, but they are stable. You can still run a very old Java on a newer Java version. And that's something I definitely love, that you know you won't break your system if you go to a newer Java version. It's not like, which happens with a lot of JavaScript frameworks, that there is new version every 6 months and you have to rework a lot or have to jump to a complete different framework. No, Java guarantees you the stability. Also JavaFX, by the way. And you can mix Java and Kotlin. So although my application is written in Kotlin, I am using a lot of Java libraries. This is the list. It's definitely not the end of the list. We will add more. But you see, like KT-MIDI is a library written in Kotlin. AtlantaFX is a theme to style your application. It's written JavaFX. Charts is a JavaFX library written by Gary Grunwald. FXGL is a gaming library written in Java and JavaFX, and Kotlin also running in this application. So I think we have to show you again some things. So one of the other views that we have here are dashboards. So again, you're looking at data flowing into an application, the same things you're creating at work, invoices being generated, orders being sold on the website, the number of visitors on your website, the number of incidents happening in the system. You can visualize them in a lot of different ways. At some point we all have to create dashboards, and JavaFX is actually a really great way to enable you to do that. As you can see, is this useful? I don't know. But is it fun? It definitely is. And it is even beautiful. It's a different way of looking at your data, something you can do with charts. Like this chart, it shows you an octave. I don't know if that's even right English word for it. So depending on where he plays on the piano, you will see other lines in this chart building up. And you see percentages and events, but how powerful this is such a nice way of showing what can be done with Java and JavaFX. Okay, next. Cleaner code, something which can also be achieved with Kotlin. On the left you have the Java version of creating a border pane. A border pane is one of those layout components you have in JavaFX. There's nothing wrong with this code. It's readable. You definitely see what's happening here. So this is perfect code. But you can do the same in Kotlin. And in my opinion, this is a bit more readable and more clear of what's happening. So on the left, you have this VBox which gets created, and then you set some properties of that VBox. While on the right, you create a VBox and immediately apply these. So these curly brackets help you to understand better what's happening and what is related to each other. So is left better or right better? There are different opinions about this. I like the Kotlin version, and that's what I've been using in Melody Matrix. If you look in the sources, you will definitely see more some parts which are still the left version because I was using the Java style of creating objects in Kotlin, while I started rewriting some of this code already to use the right side because I think that's cleaner and easier to understand. I made a blog post about this with some more examples, and then the two applications running side by side in a video, exactly the same layout which they produce, but the way how it's written is different, and I like the Kotlin version. This is the last AI generated image because we switch to virtual threads. I promise you, I will show you. Virtual threads allowed us to do something in Melody Matrix that I thought would be very complex. And before I show it to you, let me give you a short introduction. So virtual threads were introduced in Java OpenJDK 19 as a preview feature. So that's again one of these advantages of this evolution of Java. With every 6 months a new release, new features get introduced early as a preview feature. You really have to enable them if you start your Java application or in your IDE, and then you can experiment with them. So already since Java 19 you could experiment with virtual threads without the promise that they wouldn't get broken. So in version 20 there was a second preview release, and it was not sure that how you implemented in 19 would be the same in 20 or until it was finalized. In 21 it was finalized, so since then we can use virtual threads. And virtual threads are lightweight threads. So that's how they're called, because they are handled by the JVM and they are not bound to something which is specific to your machine. So the JVM runtime handles the threads. And there's no one-to-one mapping between threads. We will give you an example of that. So traditional threads. Imagine you have a machine which can have 4 operating system threads to handle tasks simultaneously. Traditionally, with Java threads, you had a task which got assigned to an operating system thread. So in this case, you would be able, or you could handle 4 tasks at the same time with 4 operating system threads. Now, if you have a 5th task, it has to wait until one of the other 4 is finished. That means that your system is blocked. Do we have something? Okay, blocked. Now, virtual threads work completely differently. And now we have some light music. So stuff starts to happen magically. You can create just as many threads as you think you need. So in this case, we have a lot of them. And the first 4 tasks get assigned to the operating system thread. Now imagine the second thread gets blocked, the second task gets blocked, and it gets blocked because it's waiting for an API to answer, it's waiting for a database to get a query, it's waiting for a file to be read, a socket to be opened, or a network connection. So it could be any kind of task and it gets blocked. As soon as it gets blocked, the JVM parks it again and takes another one. And so it goes on and on and on. So as soon as a task is no longer blocked, it can become some task that gets handled, and so on and so on. So the system, the JVM, will pick these tasks from a to-do list, try to handle them, and as soon as they get blocked, put it back on the to-do list and get it back as soon as some resource is available, an operating system thread is available to handle it. So at the end, all these tasks get done, and our system is able to handle a lot of different things at the same time. Now use it with care. It doesn't solve all problems. It's very good for concurrency, meaning switching between tasks which can get blocked. So waiting for a database, the API, those kind of things. It's not for long-running tasks. So if you start a task which gets a lot of data and then processes it to calculate results and averages and stuff like that, doesn't have blockers in between. So it doesn't make sense to make this a virtual thread. It is something which is long running because it has a lot of work to do. So you don't need to make it a virtual thread. Now, let me give you a code example. It's very similar in Java. You create a thread or you create a thread of virtual and you can start it and you can handle it, let the JVM handle it. So from code point of view, they're very similar. So it could be easy to just select a virtual thread for everything, but please be careful. As I said, it's not a solution for every problem. Now, what happens with a MIDI recorder that we create, a MIDI recording that we create in Melody Matrix? So it's a timeline. So each time he presses one of these keys, you get those three bytes of data and a timestamp. When did this happen? So we have the timestamp of the very first event, then all the other events with the timestamp and the bytes of data, and the difference between those timestamps is when did it play in that timeline. In Melody Matrix, we save this as a very simple JSON file. We have the start timestamp, and then for each event within the MIDI, we have again a timestamp and the 3 bytes of data. Now, if we read such a recording back, we can play it back. And playing it back means that we have a MIDI data player with a certain timestamp, with the data, sorry, and then the timestamp when it has to fire. And we create a virtual thread for each event of a recording. So if 100 notes are played, we start 100 virtual threads. Actually 200 because you have the press and the release. So, and what is such a task doing? Actually, it's just sleeping. It's sleeping until it has to fire or send that MIDI data. So if we start a playback and it has a note which has to be played within 10 seconds, it will sleep for 10 seconds and then send the data. So we have all these threads actually just sleeping. And that's a blocking operation. So the JVM can just put it aside, take another one, check it, did it already sleep long enough, handle it, and otherwise put it back on the to-do list. So that's what we are solving with virtual threads in Melody Matrix, is playing back a recording. Let us show it. Oops, wrong window. So this is the application again. So we have this record button. And we'll let Vic play something. Okay, this was a recording of 270 events. About. Okay, I have here a counter. So this counter is showing how many virtual threads are scheduled within the application to be played back. I have my MIDI output is set to the piano. So Vic is taking his hands off the piano because we are playing back the recording to the piano. So let's see what happens. So what you hear is the piano. So the piano is playing back the recording that we just made. And you see that all these virtual threads are counting down. So all the notes that Vic played are now sent back to the piano. I talk too much, but did you hear a difference between what Vic played before and what the application sent back? In my opinion, we should probably measure this in some scientific way, but I didn't hear a difference. So what Vic played and what the application played was actually very similar. So let's record a bit longer piece. Let's go over the 1000 events. hardest part about the magician is stopping him. Thank you. Okay, so we have this recording. You see it here. It has 1261 events. So again, let's try how this sounds. Of course, the musician thinks he's better than the computer. These are just a few examples. So we created one with 270 threads, now with 1200 threads. People have been blogging about this and they started over 100,000 virtual threads without any problem. The main difference between a traditional thread is that a traditional thread takes up several megabytes of memory from your system, and a virtual thread is just a Java object being handled by the JVM. So that means that it's a very small amount of memory that is needed and a very small amount of CPU and power that is needed to handle it. Okay. Now, as they say in pet projects, everything becomes more fun with the LED strip. And although we're talking about software here, let's see what we can do with that. So as another pet project, a few years ago, I started writing about Java on Raspberry Pi. I started learning about electronics and how you control electronics to a Raspberry Pi and Java. It ended up in a book. The paper book that you see here is sold out, but you can still buy the ebook, and I keep updating the ebook. By the way, this slide is outdated because last week I changed this to update 2025. I'm updating some of the content and some of the examples to use the latest versions of Py4j and other libraries, and of course Java. The book was still written with Java 11 in mind, but it should have been now 17, and I will use 21, a lot more in the book. And yeah, hopefully next year another long-term support version. Because I wrote this book, I have a lot of electronic stuff laying around. I also document the Py4j project, which is a library to control electronics on the Raspberry Pi. So I have LED strips. I have this little controller that you see here, which is a stereo device where you can connect up to 8 LED strips, if you give it enough power, of course. And serial communication is again something which is old, maybe even older than MIDI, is a way to send data over a wire to another device. Most computers nowadays don't have a serial connection anymore, so I have this here somewhere on my desk, an USB to serial connection. The little board is hanging here. I don't think you can see it below the piano. And we'll try to connect a LED strip to the application and see what's happening. So again, I already have the data, already have the MIDI data. I just needed to create a new user interface to see what will happen and to control it, to change the colors. And sending colors to such a LED strip is actually just a byte array. A byte array of RGB values, red, green, blue. So we can take the color again of the box that we see on the screen, create a byte array out of it, and send it over the serial link to the device. This is the part of the presentation that can probably go wrong. So we'll see what happens. So I have here the view. Okay, let's see what happened. So you have this view here again. I can change the colors of these blocks. And okay, this is already looking good. We have here, this is my USB to serial converter cable. And it has there are also 8 checkboxes here, slider boxes, because I can control up to 8 LED strips. There's only one connected here on line 1, channel 1. So see what's happening. Oh yeah, let's change camera. So what you see now is actually the LED strip being controlled from the application here. I can change colors. Completely black on one side, and I can control the width and the duration. Okay, and let's make it a more psychedelic and add some colors for the other keys. So again, every LED is related to one node. So each event that he sends through the piano comes into the application sends it to all the views, and all the views visualize it in one way or another. So this is the LED strip, but I can still keep this open and go back to the piano. Oh no, that's a bad demo. I can still go back to the charts. So you see the same data. By the way, what you just saw was a bug. You cannot open the piano view twice in the application, so I have to investigate why this is happening. But you can see, so all this data is coming in, and we can still have all these views open at the same time and visualize the MIDI events. Okay, okay. I will keep the LEDs open because they're fun. So indeed, every project becomes more fun with LED strip. As I said in the beginning, I wanted to create the views as an open source project because I want to show to other people what you can do with JavaFX. I'm definitely not the best JavaFX developer. I just love to use it. I love to create stuff with it, and I love to show what can be done with it. So if you go to this GitHub project, you can find the views, and the views are part of the application that we distribute, but this repository is open source. And let me show you. So if I stop the other application now. So what this viewer project provides is everything which is melody matrix without the recordings and without the interaction with the instrument. So there is on the left side, you see, 1 minute, you don't see it. And now it's going wrong because I want to show you this extra window. At the window. Okay, there you have it. Good. On the left, you have a simulator of an instrument. In the middle, you can select the view, and then this is a test of the license. So let me show you this. So this is the same view that we've seen before, controlled by the piano, but in this application, I can play random notes, and again, you see how things are happening. So the goal of this project is to have a standalone thing, which is easy to run. It has both a Gradle and a Maven definition, so you can run it from both. And you can try this out. So you can debug this, you can see how this happens. I hope that people join this repository and will come back to us with improvements. If you have an idea of an extra view which can be added to the application, please let us know, make a merge request, or think about how it could be implemented. And I want to show you, so there are different things like also the piano is here. So you have everything here to test a view. How would it look like if I would have it opened in Melody Matrix and connected to an instrument? You can also really push the boundaries. I don't think that Vic can play this fast. He can play very fast, but this is super fast. So this is just to test. This is just a demo of trying out what can be done. By the way, if someone has experience with FXGL, so FXGL is the game library, the JavaFX game library used to create this effect, this view. If someone has experience with game engines and animations and can help us to make this more beautiful, so Vic really wants this to be more fireworks-like, so not just dots being flying around, but really fireworks. If you have some ideas there and ways on how to implement that, it's just basic Java code, please tell us and help us here. So if I can show you, so the test application is a very simple application, a JavaFX application, which starts the test view. But if you go, for instance, in the piano generator, what you see here is the particle initialization, so how particles are animated. And it has an explosion emitter, so that's making those dots fly over the screen. And then there's, yeah, actually just mathematics, having stuff, changing it and flying around. And so this could be extended a lot to make it more beautiful, animate it more. And we're really inviting you to join this and help us here to make this better. Okay. So for the LED strip, there's also here, like here you find this code to send the RGB values to the LED strip to one of all the selected channels, 0 to 8. So you will find a lot of these codes. This is the concentric plate nodes, one of these charts. You see that creating such a chart in this code becomes very easy. You just have a list of items you want to show on the chart. You define which kind of chart you want to use, add it, and then on every node that Vic plays, it's added to the chart data. So a lot of examples here, JavaFX examples, what you can do with it. Please take a look into the project if you're interested in contributing or using this yourself. Okay, we're nearing the end of the presentation, so we will have time for some questions if there are. If you want to contribute, please visit the website melodymatrix.rocks. We have to be honest. We didn't sell any license yet, but we do invite you to download the application. It is a fully running application for free. You can run Melody Matrix without paying anything for it. It's only when you want to create a recording, save a recording, export as a video, stuff like that. Those are the things we will make hidden under license, but you can already play with it. We presented this at Devox and at JFall, and then I got some feedback from a developer who did not play music, but his father is a pianist, and in the weekend they were trying it out, and yeah, just the developer and his father having some good time with this application and trying how they could animate it. And if you want to contribute, call us and help us make this application better, and maybe share with others what can be done with JavaFX. What's next? I invite you to visit my website, webtechy.be, of course also fuji.io, if you want to learn more about Java, JavaFX, and all the other amazing things which are happening within the OpenJDK world. And of course, try Melody Matrix, the application. You can find it on the website melodymatrix.rocks. I didn't even know that rocks was a domain name that you can register, but here we are, because .com was already taken. Have fun, visit the website, and I hope you learned something from this presentation. Thank you.
Right. Frank, Vic, thank you very much. That was awesome. We have one question, but I wanted to display a couple of quick comments. Vincent said Bella Ciao, then Carantella. I guess that was earlier. And Marianne Varga said, definitely a talk with the best soundtrack. I would have to agree with that.
I don't think there are many Java talks with a live music player.
We could start a new trend.
Well, we have Hanno Embrechts from the Netherlands who is doing talks with his guitar and singing even. I won't sing. Will he sing? No. we won't sing. No, that's not a good idea.
I won't sing either. So, and then the only question really here is for a Java developer, how much time did you need to learn coding in Kotlin?
None. Is the very short answer. No, if you use, of course, we have IntelliJ IDEA. If you paste Java code in a Kotlin file, it will tell you how it could be improved, how it could be converted to Kotlin. So that's the first thing. I've done that. I just taken some JavaFX code, copied it to Kotlin file, and then see what happens. How did it rewrite the code? It's very, very, very similar. What I didn't do yet with Kotlin is really use the features that you get with Kotlin that don't exist in Java. Like you have coroutines, which is some kind of virtual threads, if I understand it correctly. I didn't use it yet. And there are other libraries and other tools you can use in Kotlin. So for me, it's just at this moment, learning the language. How do I write things that I can write in Java? How do I write them in Kotlin? But if I really want to learn everything, Kotlin has multi-platform, which is a way also to build, is it multi-platform? Is it called differently? I don't know, to create user interfaces. But I love to do that with JavaFX, so I'm not going to do that with the Kotlin way of doing it. So you can abuse Kotlin a bit and use it as you wish in combination with what you know from Java. So I'm not a Kotlin developer, because a Kotlin developer builds everything in Kotlin. You can even have GitHub actions created in Kotlin. And you can use the technology that Kotlin provides, which is other than what you know from Java. So there I will need some time, that's true. But just coding in Kotlin is just trying it out, and you will get started very fast.
All right, so new question just arrived from Marianne, and he asked, but why did you choose Kotlin in the first place?
In the first place, because I'm using the KT MIDI library, so it's a MIDI library written in Kotlin. And on the other side, I have so many things on my to-do list that I still want to learn. My to-do list is on the wall there, that's why I'm pointing. There's so many things I want to learn. And if you have a pet project, it's the ideal moment to try to learn something. So I thought, let me just try it out. And again, it led me to a first blog post of comparing JavaFX in Java versus JavaFX in Kotlin. So that was the first result. So it also allows me to create content for Fuji, for my own blog, and to share on a conference like this. So for me, it's just, I wanted to learn Kotlin, and this was the ideal project to do that. So that's why I combined them.
Awesome. At the moment, I don't see any other questions. So folks, this is your last chance to get something in there if you would like to have any questions for Frank or for Vic himself. So thank you, Vic, by the way, for the music. I was going to ask if you knew any rock and roll, you know, like for my time. You know, Bon Jovi or
Bon Jovi, metal. He's really into metal, but I don't think that's jazz.
Oh, jazz is cool.
Jazz is cool. That says, do you think some of the Kotlin features should be added to Java in the future?
Oh, I saw. Okay, yes.
Yeah,
I just saw that.
The nice thing about Java is it evolves slowly, but it indeed takes improvements from other languages. And for instance, the records we now have in Java, I'm not saying that they're copied from Kotlin, but they are inspired by things that are happening in other languages. Virtual threads, is it a copy of coroutines from Kotlin? I don't think so, but they inspired each other. They were missing in Java, virtual threads, so Kotlin and other languages did something which looks like virtual threads we have now in Java. The good thing about Java and this 6-month release cycle and these preview features, they don't jump on new trends within OpenJDK. It's not because someone else is doing this that Java or OpenJDK will do it immediately. They really have a plan for the future. The whole thing with switch expressions and instance of all these improvements in all these versions next to each other of Java, they all lead to something. And records, for instance, records were designed as records as they are now, because they could be used in instance of at some point. So if something new appears within the software world, and it should happen in Java, it will not happen because it's a good idea. It will happen because it fits in this strategy of having something which is stable and which brings improvements to developers, to runtimes, to what you can do with Java, but at a steady pace, so to make sure that nothing gets broken along the way. And that's also some of the advantages of the preview features. So they give it to the users to get feedback. Is this the way you want it to be implemented in Java? Like we have, what is it, text templates or string templates, what is the name? It was a preview features in a few releases and it got removed in the last one because it was not good enough. People were not happy with it.
String templates, I think.
Yeah, string templates. So it will probably come back later in another form or in another way of implementation. And that's the good thing about it, this evolution in Java. It's not super fast, although we have 6-month release cycle, which is already, no one believed when they announced we were going to do 6-month releases. No one believed that this would succeed. And it actually is the strength of the current Java versions. It is how Java evolves and how it brings new developments. And that's one of the things, of the reasons why I love Java indeed.
All right. Marianne said, inspiration is the key, and this talk is very inspirational.
Thank you. We tried our best.
You guys did awesome.
Okay.
There's no more questions. First of all, thank everybody for joining us. I've seen a lot of familiar names, since last Thursday when we started all of this, and we have a couple more talks and then all day tomorrow. The next session is from Peter Laurie, lessons learned from founding my own company and 30 years of hands-on coding. So you can find that in your YouTube link. And if there's nothing else, oh wait, hold on. We have one last question. While using threads, how do you decide how many threads will our app need? I understand the general principle states we must consider CPU intensive or IO intensive tasks, but what's your take on this?
The whole concurrency and threading is a very complex topic. There are books written about it. It's a matter of really dimensioning your system, and yeah, it depends, is again the answer. Eh? In our case, Melody Matrix, the virtual threads are a perfect solution to cover the whole process of playing back this music. So we can handle that with virtual threads. It's perfect for what we need. If you indeed have a CPU intensive or IO intensive task, as you say here, the only way you know is testing, is trying it out, have it in production, testing in production, which is not so well taken advice. But a lot of these cases, I work for Azul, and at Azul we have clients which have very heavy systems. And reproducing your production system in a test environment to really see the impact of the load is very difficult. So a lot of these cases, you can only test it in production or spend a lot of money on setting up a test system which really reproduces how things will work in production. And that's a very hard thing. So CPU intensive tasks, IO intensive tasks, try it out. That's the only advice I can give. You really have to see how your system behaves. Make sure that you have the good measurements like you have in Spring, these actuators and all these health states that you can get. Those are and then also, of course, the metrics of your system itself. Those are the things I can advise. But yeah, I'm definitely not a thread specialist. I advise you to read some of these books about these topics. And yeah, see how your system behaves in production and be sure you have the right tools to measure how performant your system is.
All right. Awesome.
Okay. And my pianist left already.
Yeah. All right. So I want to thank everybody again, and we'll see you throughout the rest of the conference.
Okay. Thanks for joining.